Hello viewers, welcome to Senior College Mathematics. Topic of discussion is partial fractions. Lesson 1, the concept of partial fractions. Consider the following rational expression: 2 over s plus 1 plus 3 over s minus 4. To simplify this fraction, you have to find the LCM of the denominators. You have it in this form. To continue, you divide the LCM by each denominator, your answer times the corresponding numerator. If you divide the LCM by the first denominator, you are left with s minus 4 times this numerator. You have this result, plus the same LCM divided by this term. You are left with s plus 1 times this numerator. You have this result. If you expand the numerator, you have this result. When you add like terms, 2s plus 3s, that is 5s, minus 8 plus 3 is minus 5 over the denominator. The fractions 2 over s plus 1 and 3 over s minus 4 cannot be made simpler than the form in which they are now. That is true. They are said to be partial fractions of the fraction this. The fraction this, on the other hand, is said to be the compound fraction of the partial fractions. Why we call these fractions partial fractions? The result obtained when they are simplified is called compound fraction. Now, suppose that we want to reverse the compound fraction to the respective partial fractions. That is, suppose we are given the rational expression 5s minus 5 over bracket open s plus 1 bracket close bracket open s minus 4 bracket close, and we want to express it as the sum of two rational expressions called partial fractions. In other words, we want to break this complex or compound fraction down into simpler fractions called partial fractions. The process of transforming a compound algebraic fraction into a sum of partial fractions is called partial fraction decomposition or resolution into partial fractions. By convention, our partial fractions must be proper in the sense that the degree of the numerator must be less than the degree of the denominator. In this series of teachings, we are going to consider improper fractions later in the series. But for now, we are concerned with proper fractions. Also, they must be in their simplest form, in the sense that they must not split into other fractions. Partial fractions are characterized generally by the nature of factors at the denominator of the compound fraction we are required to resolve or decompose. Let f of s and g of s be polynomials with real coefficients such that the degree of f of s is less than the degree of g of s. That is proper fractions. The indicated quotient f of s over g of s can be decomposed or resolved into partial fractions as follows. In this place, we want to explain the various categories or groups of partial fractions. Number one, if g of s has a linear factor of the form as plus b that is non-repeated, then the partial decomposition will contain a term of the form a over as plus b. In other words, if the denominator has a linear factor, that is just one, you assign one numerator to it, represented by capital letter A, where A is constant. The second category is that if g of s has a linear factor of the form as plus b raised to the kth power, here it can be power of 2, power of 3, and so on. That is, the linear factor is repeated, then the partial fraction decomposition will contain terms of the form a sub 1 over as plus b plus a sub 2 over as plus b in brackets to the power of 2 plus dot 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 plus a sub k over as plus b in brackets to the power of k. For instance, if the linear factor is raised to the power of 3, it means you are going to assign 3 numerators starting from power 1, 2, and 3, where a sub 1, a sub 2, a sub k are constants. The third category, if g of s has a quadratic factor of the form as squared plus bs plus c or higher powers, where b squared minus 4ac is less than 0, then the partial fraction decomposition will contain a term of the form as plus b over as squared plus bs plus c. So when the factor is quadratic, you have to assign a linear factor that has two coefficients in the numerator, as in as plus b, where a and b are constants. Category 4. If g of s has a quadratic factor of the form as squared plus bs plus c, or higher powers raised to the kth power, that is, when the quadratic factor is repeated, then the partial fraction decomposition will contain terms of the form a1s plus b2 over the quadratic term plus a2s plus b2 over the quadratic term to the power of 2, and so on, where a1, a2, a sub k, and b1, b2, b sub k are constants. The above properties apply to proper fractions. In the case where the degree of f of s, the numerator, is equal to or greater than that of g of s, long division of polynomial is applied before decomposing into partial fractions. This group is also known as improper fraction, when the degree of the numerator is equal to or greater than the degree of the denominator. We shall discuss 3 methods of decomposing compound fraction into partial fractions. End of lesson 1. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared. Goodbye.